In the past, we know that 2 squared is 4. 2 to the third is, anybody know that one? 8. If I asked you what value of x would make 2 to the x equal 6? 2 squared is 4, 2 to the third is 8. So what we'd have to do is maybe guess 2.5 and try 2 to the 2.5 and see if that gave us 6. If it didn't, we'd have to try something else. But basically, we only have guess and check. We can't solve this equation because we don't know how. Today we're going to learn about logarithms, which will allow us to solve this equation and find the exact value of x that when you did 2 raised to that number, you would get 6. Technically, this blank needs a y is greater than 0 in there. There is a small error here where it says logarithmic. If you could cross out the I and the C. Sorry about that. The logarithm of y with base b is denoted by log base b of y. And it is defined as follows. The log base b of y equals x if and only if b to the x equals y. On the left is logarithmic form. On the right is exponential form. But these two things mean the exact same thing. We're going to use these two things to learn how to switch from one form to another. The biggest thing you need to know about logarithms is how to change from logarithmic to exponential and how to change from exponential to logarithmic. So, how many of you have been on the log ride at Worlds of Fun? You get in the little log boat thing and you go down this big thing and you splash and then you go kind of around and underneath. Okay, we're going to do the log ride today. So, I'm going to put my pencil at the little B on log, and then we're going to go, woo, and do the log ride. So, starting at the base, around the equal sign to the x, and then up and around to the y. We're going to call that the log ride. And if you say, woo, when we write it, more power to you. I'm totally fine with hearing woos in the middle of the test. Now, the reason I drew this log ride in, this shows us which order to write the letters in exponential form. So notice exponential form is b to the x equals y. Log base b, go around the other side to the x equals y. So this log ride shows you which order to write the letters. We can also do the log ride on the exponential side, starting with the base b. Woo! Log base b of y equals x. It shows you which order to put things. Another thing that's helpful to write is log base answer equals exponent, and base to the exponent equals answer. The expression log base b of y, that little symbol, is read as log base b of y. The other thing we need to talk about is how to write these things. So, in elementary school, do you remember when you had paper that looked like this? And you had to practice your handwriting on paper that looked like basically a road? So we would write this log base b of y equals x. So notice the log, the y, and the x are all in the same line, same size. The only thing that's different is that the b is smaller and slightly lower. That's called subscript. If you don't write your logarithms correctly, I will take points off because how you write those numbers, where you write those numbers is very important. Okay, let's practice in 1, 2, and 3 These are logarithms. We are going to rewrite them in exponential form. So start with the base, the little number that's lower, and do the log ride. Woo! So we start with the 3. What number am I going to write next? 2, so that's the exponent, equals 9. And does it make sense? Does 3 squared equal 9? Yeah, 3 squared equals 9. So because 3 squared equals 9, the log base 3 of 9 equals 2. These two statements are equivalent. So let's try number 2. Start with the 8. Y'all gonna woo with me? Yeah? 1, 2, 3. Woo! See how much fun that is? It's so much fun. 8 raised to the 0 equals 1. Try number 3 on your own. Okay, 5 to the negative 2 equals 1/25. Now let's go the other way. We'll start with exponential and we'll go backwards into logarithms. You can still do the log ride, so start with your base. The base is the thing being raised to the exponent. Woo! That means we're going to start with the 6. So we write log base 6 of 36 equals 2. It is definitely not log base 6 times 36. That is, no. It's log base 6 of 36 equals 2. So on a test, I might give you as a bonus question this statement and say, write this using words. And if you write it correctly using words, you get bonus points. So keep that in mind and start practicing saying these correctly. Log base 6 of 36 equals 2. On number 5, start with your 16. Woo!
Log base 16 of 1/16 equals -1.
Oh, my 5th hour is awesome. You don't have to put 1/16 in parentheses, but anytime you have something like that inside the log, it is helpful if you have parentheses in there. So try number 6 on your own, although I think you've all got this. Evaluate the expression log base 3 of 81. Now, what they want you to do on here is put this equal to x and then switch it around and guess and check. So this would be 3 to the x equals 81, and they want you to figure out what that is. If they say evaluate this without a calculator, it should be a whole number and you should be able to figure it out. So 3 squared is 9, 3 to the 3rd is 27, 3 to the 4th is 81. So the log base 3 of 81 is 4. But wouldn't it be nice if we could do this in our calculator? So grab your calculator, doesn't matter which type of calculator you have. To do this in your calculator, I'm actually old enough that I can say, well, back in my day, you could not do the log base 3 of 81 in your calculator. If you see the LOG button on your calculator, that is log base 10. That button only helps you if it's log base 10. So we can't use that. However, there's this thing called the change of base formula, which is farther in your packet. But the change of base formula allows you to change this from base 3 to base 10. To use the change of base formula, you would do log of the number inside the log divided by log of the base. So you can do that in your calculator. Log button of 81, close the parenthesis, divided by log button of 3, and the answer is 4, which is what we got. So when you're using the change of base formula, the important thing is the base needs to be on the bottom. So log of whatever number is inside divided by log of your base, and that will give you your answer. Now, if you happen to have one of these fancy TI-84 plus Cs, there's a little feature that didn't exist when I was in high school. Push your alpha button and then the window button, which is right next to y equals. When you push alpha y equals, this fancy menu pops up, and look at option 5 on this fancy menu. Option 5 is log base. So I select log base, and look, it lets me stick in log base 3 of 81, and it will calculate it for me. So the newer calculators have log base whatever programmed into them. You just have to know how to get there. So the trick is alpha button, window button, and then it's option 5, log base. For 8 and 9, you can either use the change of base formula or the log base feature of your calculator, whichever, but try both of those out. The log button on your calculator is called the common logarithm. The common logarithm is base 10, and we simply use log for log base 10. So anytime you see log with no base, kind of like in number 10, see how there's no base? If you see log with no base, that means that it's base 10, it's the common logarithm. So to do number 10, you would punch the log button, and then 5. The log of 5 is 0.699. ln is called the natural log. The natural log is base e, and we use ln to represent the natural log. So when you see ln, I'm sorry that my view keeps going funky. When you see ln, it means log base e. This is one of those times when I want to toss the computer out the window, you know? When you see ln, it means log base e. So ln button of 0.1 should give you negative 2.3.